Hello everybody, Happy New Year. This video is going to be a overview of a optics, waves, and modern physics undergraduate physics course. In a course like this, the curriculum that is followed is typically light and optics, modern physics, and interspersed between both of those is waves. Over here, I have Physics for Scientists and Engineers, the 10th edition, which has the following brief contents. Previously, we looked at electricity and magnetism in part 4. At the end of that section, there is a discussion on electromagnetic waves, and then you lead right into part 5, the nature of light and optics. Part 5, light and optics. It looks like it's about 100 pages. Section 34, the nature of light and the principles of ray optics. Section 35, image formation. Section 36, wave optics. Section 37, diffraction patterns and polarization. Part 6, modern physics. Section 38, relativity. In this 10th edition, we only have part 5 and part 6, but I have over here Physics for Scientists and Engineers, Survey and Jowett, the 7th edition. Here's the contents of the 7th edition. Mechanics, Part 1. Part 2, Oscillations and Mechanical Waves. Part 3, Thermodynamics. Part 4, Electricity and Magnetism. Part 5, Light and Optics. Looks like it's the same 4 sections. Part 6, Modern Physics, is a bit larger. We have Section 39 this time, Relativity. Section 40, Introduction to Quantum Physics. Section 41, Quantum Mechanics. Section 42, Atomic Physics. Section 43, Molecules and Solids. Section 44, Nuclear Structure. Section 45, Applications of Nuclear Physics. Section 46, Particle Physics and Cosmology. So now that we have those out of the way, let's go into the main contents, detailed contents. Part 5, Section 34. We start with the nature of light. What is light? How do we think of it? The following section is the ray approximation in ray optics. So an explanation of light happens in the opener, and then we see that the ray approximation is a good way of visualizing it in optics. Analysis model, wave under reflection. Analysis model, wave under refraction. So two different things that a light wave, could undergo. Section 34.5, Huygens principle. Don't know what that is. Section 34.6, dispersion. 34.7, total internal reflection. Section 35, image formation. We have images formed by flat mirrors, spherical mirrors, formed by refraction, and thin lenses. Then we have lens aberrations and optical instruments. Section 36 is all about wave optics. We talk about the Young's double slit experiment, an analysis model, waves in interference, intensity distribution of the double slit, interference pattern, change of phase due to reflection, interference in thin films, and the Michelson interferometer. Section 37, diffraction patterns and polarization. Introduction to diffraction patterns from narrow slits, resolution of single slit and circular apertures, the diffraction grating, diffraction of X-rays by crystals, polarization of light waves. Part 6, Modern Physics. Section 38, the principle of Galilean relativity, the Michelson-Morley experiment, Einstein's principle of relativity, consequences of the special theory of relativity, the Lorentz transformation equations, the Lorentz velocity transformation equations, relativistic linear momentum, relativistic energy. We end with the general theory of relativity. That is for the 10th edition. Now let's check back onto the expanded contents of the 7th edition. The nature of light, measurements of the speed of light, the ray approximation in geometric optics, wave under reflection, wave under refraction, Huygens principle, dispersion, total internal reflection. Looks like the same stuff as the previous chapter. Image formation, images formed by flat mirrors, spherical mirrors, refraction, thin lenses, lens aberrations, the camera, the eye, the simple magnifier, the compound microscope, the telescope. Interference of light waves. Conditions for interference, Young's double slit experiment, light waves in interference, intensity distribution of the double slit interference pattern, change of phase due to reflection, interference in thin films, the Michelson interferometer, diffraction patterns and polarization. Introduction to diffraction patterns from narrow slits, resolution of single slit circular apertures, the diffraction grating, diffraction of X-rays by crystals, polarization of light waves. Modern physics, relativity, the principle of Galilean relativity, the Michelson-Morley experiment, Einstein's principle of relativity, consequences of the special theory of relativity, the Lorentz transformation equations, the Lorentz velocity transformation equations, relativistic linear momentum, relativistic energy, mass and energy, the general theory of relativity. Introduction to quantum physics, the blackbody radiation and Planck's hypothesis, the photoelectric effect, the Compton effect, photons and electromagnetic waves, the wave properties of particles, the quantum particle, the double slit experiment revisited, the uncertainty principle. Quantum mechanics, an interpretation of quantum mechanics, the quantum particle under boundary conditions. The Schrödinger equation, a particle in a well of finite height, tunneling through a potential energy barrier. Applications of tunneling, the simple harmonic oscillator. Atomic physics, atomic spectra of gases, early models of the atom, Bohr's model of the hydrogen atom, the quantum model of the hydrogen atom, the wave functions for hydrogen, physical interpretations of quantum numbers, the exclusion principle, and the periodic table. More on atomic spectra, visible and X-ray, spontaneous and stimulated transitions, lasers, molecules and solids, molecular bonds, energy states and spectra of molecules, bonding in solids, free electron theory of metals, band theory of solids, electrical conduction in metals, insulators, and semiconductors, semiconductor devices, superconductivity. Nuclear structure, some properties of nuclei, nuclear binding energy, nuclear models, radioactivity, the decay processes, natural radioactivity, nuclear reactions, nuclear magnetic resonance, and magnetic resonance imaging. Applications of nuclear physics, interactions involving neutrons, nuclear fission, nuclear reactors, nuclear fusion, radiation damage, radiation detectors, uses of radiation. Particle physics and cosmology, the fundamental forces in nature, positrons and other antiparticles, mesons and the beginning of particle physics, classification of particles, conservation laws, strange particles and strangeness, finding patterns in the particles, quarks, multicolored quarks, the Standard Model, the cosmic connection, problems and perspectives. So here's a 2-page view of the expanded contents of what I just discussed here. As you can see, it is quite a lot of information, but it's a good idea to get a bird's eye view of this stuff. Slowly but surely, you can learn each of these concepts. In the span of 3 months, 4 months, you can get a taste of each of these ideas. You don't have to master all of them. So I hope this video was helpful. I hope you enjoyed, and we're going to cover everything I discussed here by the time the summertime comes. Let's go.